Okay, so this is a hands-on lesson, so we're going to go ahead and go right in. Turn to page 561. Make sure you're on page 561. Lesson 1, use models to add like fractions, and you will need your fraction tiles for this. So make sure that you have your fraction tiles. Okay, so first, read the sentences under the title Kingston.
A unit fraction,
Very loudly.
a unit fraction has a numerator of 1 and a numerator of 1. It is one of the equal parts of the whole. The fractions that have the same denominators are called like fractions. You can use models to add like fractions.
So let's write ourselves some notes to the side. We're going to make a small little chart. So go ahead, it's just going to have 4 pieces. One side is going to be labeled unit, fraction, or table. The other side is going to be labeled like fractions. Now, using the definition that we already know and what Kingston just read as a reminder, Zadie, tell me a unit fraction. 1/6. So now we have our little table, and we have an example of a unit fraction. Who thinks that they can tell me an example of like fractions? Using the definition that Kingston just gave us, fractions that have the same denominators are called like fractions. I need somebody to give me an example of like fractions. Lena.
2/5 and 4/5.
Very good. So 1/6 is an example of a unit fraction. 2/5 and 4/5 are examples of like fractions. 1/6 is a unit fraction because it has a numerator of 1. 2/5 and 4/5 are like fractions because they have the same denominator. They each have 5 as a denominator. Very good. Now that's going to be really important for this lesson. So keep that in mind. Make sure that your little table is easy to read and easy to see. Your handwriting is neat. You're not squishing it all together to make it fit in the smallest tiny spot. And I'm going to go change the page, so make sure you... Okay, everybody, finger or pencil on the Build It. And read in your head while I read out loud. Abigail is playing a board game with her friends. So I'm imagining she's having a slumber party and they're playing a board game. There are 5 game pieces. So I'm imagining it's something like Sorry or Monopoly where there's like 5 different colors of little plastic pieces, or 5 little different objects like in Monopoly that move around the board. There is a red piece, a blue piece, a yellow piece, a green piece, and a purple piece. Okay? What is the total fraction of pieces that are yellow, green, or purple? Well, let's figure out the fraction for each one. How many total pieces are there, class? 5. So that means our denominator is 5. Because out of 5 pieces, we're figuring out how many are yellow, green, or purple. Out of those 5 pieces, how many are yellow, class? 1. So 1/5 are yellow. Out of those 5 pieces, how many are green, class?
So the statement that you guys sent.
I'm going to move this over a little bit so it's right underneath yellow, and you can do the same thing. And out of those 5 pieces, how many are purple, class?
1.
So 1/5 are purple. 1 out of 5 are yellow, which is 1/5. 1 out of 5 are green, that's 1/5. 1 out of 5 are purple, that's 1/5. So now we need to figure out, okay, what is the total fraction of pieces that are yellow, green, or purple? So what we have to do is take the fraction that represents each color, put them together. What operation are we doing when we are putting numbers together? Class? Addition. I hope you knew that, not just because you're looking at the numbers, because if I asked you that on a test, what operation shows that you're putting numbers together, you wouldn't have this to look at. You'd have to know it's addition. Remember, subtraction is where you're taking away. Multiplication is where you're repeating groups. Division is where you are breaking down into groups. So what we're going to do is we're going to use fraction tiles. We're going to use our 1/5 fraction tiles. They're green. Okay, and I'm going to pull out 1/5 to represent the yellow pieces. Another 1/5 to represent the green pieces. And another 1/5 to represent the purple pieces. You can see that right there. There's 1/5 for the yellow, 1/5 for the green, and 1/5 for the purple pieces. Now all together. I'm so sorry to interrupt. Okay. So like we were saying, we have 1/5 to represent the yellow piece, 1/5 to represent the green piece, and 1/5 to represent the purple pieces. Now we're going to add those together. 1/5 plus 1/5 plus 1/5 equals what, class?
3/5.
We have 1, 2, 3 1/5 tiles. Remember, however many of our fraction tiles we have, is that our numerator or our denominator? The number of fraction tiles that we have, is that the numerator or the denominator of the fraction? Carla?
The number of fractions we have.
Wait, just yes or no, Carla? I'm sorry, just there's only one word because you're changing my question when you say that. The number of fraction tiles we have, is that the numerator or the denominator?
Numerator.
The numerator. The denominator is whatever the denominator of the fraction tiles is. So the denominator on our fraction tile is 5. We have 3 of those fraction tiles. So we have 3/5. So the total fraction of game pieces that are yellow, green, or purple is what, class?
3/5.
3/5. We have 3 1/5 tiles. So that means 3/5 of the pieces are yellow, green, or purple. Okay, make sure you're awake. If you are listening and following along, this lesson will take you no time. The part that will take the longest is just picking out the correct fraction tiles from the bag. But you must be listening and following along. Okay. In example 1, we used unit fractions. We said 1/5 plus 1/5 plus 1/5 equaled 3/5. But what if we don't have unit fractions? What if we have fractions that we are adding that don't have 1 as a numerator? What if they are like fractions, where they have different numerators but the same denominator? Well, everybody finger on the pencil on the try it, because that's going to tell us exactly how to do that. Yes, Carla?
There is wording. There's like a sentence on top. Like in
Okay. Please read the sentence above the try it. Aaron, loud and slow.
Not all fractions are unit fractions. You can decompose or break down a fraction into a sum of units.
So, in the try it, we have 3/5 plus 3/8 plus 2/8. Those are not unit fractions. But what we can do is we can break them down using fraction tiles to show the unit fractions. 3/8 will have how many 1/8 tiles, class?
3.
3. So let's model 3/8. Yours are brown.
Yeah.
Let's model 3/8. We have our first addend, and we're going to model 3/8. 1/8 plus 1/8 plus 1/8 is 3/8. Remember, it's easiest to use your fraction tiles on the flat part of your book so they don't slide. Most of you are remembering that. Okay, so we modeled our first addend. 1/8 plus 1/8 plus 1/8 is 3/8. Now we want to model 2/8. How many 1/8 tiles are in 2/8, class? 2. So let's model 2/8. 1/8 plus 1/8 is 2/8. We're just using 1/8 tiles. How many 1/8 tiles are in 2/8? Class? 2. So you should have 2 1/8 tiles to show 2/8. We modeled our first addend, 3/8, by putting 1, 2, 3 1/8 tiles together. We modeled our second addend, 2/8, by putting 1, 2 1/8 tiles together. Step 3 is to add. We count the total number of 1/8 tiles. 1, 2, 3, 4, 5. Are these 1/8 tiles part of a different whole? Or do they all represent part of the same whole? Smith.
They all represent part of the same whole.
They all represent part of the same whole. I got them from over here, where all of my fractions represent part of this whole. You got your tiles out of your bag, and all of those fraction tiles represent part of the same whole. Your tiles are the same size as my magnetic ones. So they all represent a part of the same whole. I couldn't do 3/8 of a pizza and add it to 2/8 of a cookie, because do those pieces, these little fractions, do they represent parts of the same whole? Class? No. So I can't add these together because there's no such thing as adding pizzas and cookies. It's like when you add, you have to have the same unit, right? You can't add like 3 oranges and 2 apples and end up with 5 oranges. They don't just magically change. It's the same thing with fractions. You can only add them if they represent the same whole, part of the same whole, like our fraction tiles do. So, are these unit fractions different sizes? Are these unit fractions different sizes? Carla?
No.
No, they're all the same size. Same size, same size, same size, same size, same size. Guys, vocabulary is important. I just asked, are these unit fractions all the same size? And you guys, I know, I can see it in your faces. What's a unit fraction? What do you mean? Well, what is a unit fraction? Colin?
A fraction that has 1 as the numerator.
A fraction that has 1 as the numerator. So are all of these unit fractions the same size? Yes. They are all 1/8 of the same whole. That's why you can't add these and get the same denominator. Because these are both unit fractions, 1/3 and 1/6, both have 1 as the numerator, but are they the same size? Are these unit fractions the same size? No, they are not. What? Lena? Like fractions, so we can't add them that way. We cannot add them this way unless the unit fractions represent part of the same whole. And the unit fractions are all the same size. So now knowing that all of our unit fractions represent part of the same whole, and all of our unit fractions are the same, we can say that yes, the answer is 1, 2, 3, 4, 5/8. Because remember, the number of fraction tiles is your numerator. The denominator of your fraction tiles is your denominator. So there are 5 1/8 tiles, which means 3/8 plus 2/8 is what, class?
5/8.
5/8. Okay. Make sure you have that. Then let's look at the talk about it. Okay, helper number 1, please sanitize away. So if we look at the talk about it, it says the fraction 5/8 can be considered as the sum of 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. That's true because how many 1/8s do we have? Michaela? 5. 1, 2, 3, 4, 5. We squeeze them all together and we have 5/8. It can also be considered as the sum of 3/8 plus 2/8. We have 3/8, we have 2/8. If we put them all together, we have 5/8. But now we need to think of 2 other ways to think of 5/8 as a sum. So how else, what it's asking is how else can we decompose 5/8 into 2 more addition problems? Now you can have more than 2 add-ins. If you can think of a way to do it with 2 add-ins, go ahead and do that. If you can think of a way to do it with 3 add-ins, you can do that as well. So tell me another way we can decompose these 5/8 into an addition problem that is not 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 or 3/8 plus 2/8. Zari.
We could do 1/8 plus 1/8 plus 3/8.
We could do 1/8 plus 1/8 plus 3/8. Because if we take 1/8, 1/8, and then 2, 3/8, and we squeeze them together, we get 1, 2, 3, 4, 5/8. Very good. Yes, sorry.
Your voice started to echo.
Okay. It might be, let's see. Very good, Zari. So Zari thought 1/8. Oops, I forgot. There's like a wooden thing under here, so sometimes they don't stick. 1/8 plus 1/8 plus 3/8. Once she put them all together, they made 5/8. Okay? I need another one. Cullen, how can we do it with 2 addends? How can we decompose or break down 5/8 into another addition problem with 2 addends, kind of like 3/8 and 2/8, plus 2/8?
It's kind of like Zari's, but I did 1/8 plus 1/8.
But I'm asking you, how can we break it down so that we have 2 addends? So Zari gave us 3 addends. Yes, in order to find 2 more, we did have to figure something out that had 3 addends, because there's only one other way to make a sum using 2 addends.
4/8 plus 1/8.
4/8. 1, 2, 3, 4. Plus 1/8. If we squeeze them together, we have 1, 2, 3, 4, 5/8. Can anybody think of any other way? There's only one more way to do it. Ethan, do you have your fraction strips there?
No.
No? Okay. Let's see. So we'll have to figure something out for that.
Okay.
Kingston, can you think of one other way? Now, we're not going to be able to do it with 2 addends. We're going to have to do it with more than that. But can you think of one other way that we can decompose 5/8 into another addition problem? We know 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 will give us 5/8. 3/8 plus 2/8 will give us 5/8. 1/8 plus 1/8 plus 3/8 will give us 5/8. And 4/8 plus 1/8 will give us 5/8. There's one more way we could do it.
It was only 4 plus 1/8, but I couldn't think of anything.
Well, that's all. We're not going to be able to make another one with 2 addends. We're going to have to do more than 2. So what's one other addition problem that we can do? I can hear you. So think about it. How else can we decompose this? Kingston, look. We've already decomposed it into 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. We've already decomposed it into 3/8 plus 2/8. We've already decomposed it into 1/8 plus 1/8 plus 3/8. And we decomposed it into 4/8 plus 1/8. What's one more way that we can take these fraction tiles and separate them, decompose them, to create one more addition problem? You can use your fraction tiles should be out. So you can be using them to mess with and manipulate. That's what these are called, manipulatives. Because you can move them and manipulate them and figure out what's another way.
2/8 plus 2/8 plus 1.
So there's actually more than one. Yes! We can do 2/8. Oops, that's where the magnetic part ends. 2/8 plus 2/8 plus 1/8. If we squeeze them all together, we get 5/8. So there was 2 more ways. There's one more way that we can decompose these into an addition problem. If you don't know the answer, you should have your 5/8 tiles out and you should be moving and manipulating them. That is what they're for. Ethan, can you think of another way?
Well, I don't have my math book, but I can try.
Okay. What do you think?
Maybe.
Well, just keep thinking about it, okay? And see if you agree with whatever the person says next, okay?
Okay.
Victoria, what is one more way? I think there's just one. I think for real now, there's only one more way.
2/8 plus 1/8 plus 1/8 plus 1/8.
Correct. 2/8 plus 1/8 plus 1/8 plus 1/8. When we squeeze them all together, we get 5/8. Very good. That's what these fraction tiles are for today. They're for moving and manipulating and modeling and counting and seeing it. Seeing that 2/8 plus 1/8 plus 1/8 plus 1/8 all together make 1, 2, 3, 4, 5 eighths. Okay, let's go to the practice it. We are going to do number 3 and number 8 together. So we're going to do 3 on page 563 and 8 on page 564 together. So, helper number 1, please sanitize, erase, sanitize. Okay. The directions for number 2 and 3 say model the sum using fraction tiles. Draw the model, then add. Well, lucky you. You have fraction tiles, so you don't have to draw it. But I need to see you using those fraction tiles. Otherwise, it's just a guess at this point. You're guessing how to do it. And you may end up right, but if you guess to get the right answer, do you know this is right, I'm gonna get a 100? You don't. So, Aaron, number 3, we have 4/8 plus 2/8. We're gonna use our 8th tiles again. What do we do first? We model our first add-in, which is, what is our first add-in? 4/8. Which fraction tiles are we using? 1/8. How many do we need to model 4/8? 4. So we need 4 1/8 tiles. 1, 2, 3, 4 to represent 4/8. Now what do I do, Aaron?
We model 2/8.
I model 2/8. Which fraction tiles am I using?
1/8.
My 1/8 tiles. How many am I using?
2.
2. 1, 2. So I have 4/8 and 2/8. Now what do I do? Bless you. Bless you. We add them. When I'm using these manipulatives to add, what do I do with the two groups? I just put them together, squeeze them together, move them, manipulate them. Now what do I do to figure out what the answer is? I count the fraction tiles. So Aaron, count as I point.
1, 2, 3, 4, 5, 6.
How many 1/8 tiles do we have? 6. So 4/8 plus 2/8 is 6/8. Now if one of these fractions had had a different denominator, would I be able to add them like this? No, because they wouldn't represent parts of the same, I'm sorry, the unit fractions would not be the same. I couldn't add 4/8 and 2/5 to get 6/8 because is the denominator 5? Does this represent the same amount of space as this? No. You'll learn about that in 5th grade. Because you can do it, you just have to do something else. You'll learn how to do that in 5th grade. So make sure that you're listening carefully in 4th grade so that when you get to 5th grade, adding fractions without the same denominators is easy. Just one extra step. Okay, everybody understand how to add the fractions like this? Let's talk about the rest of this page, and then we'll do number 8 together. So, of course, number 2, you're doing the same thing. I need to see you using the fraction tiles. Number 4, you're using this table. It's kind of covered up by our little table that we created, but you can see it on your page. You're using it to answer numbers 4 and 5. Number 4 asks you about a rule. What else could you do other than using models to add like fractions? Think of the pattern. Remember, a rule tells you how to find the next, bless you, the next term in the pattern. So think of a rule that tells you how to add like fractions without using models. Then number 5, you're using this rule to solve a new problem, which means for number 5, are you going to use models? No. But for every other one, you're going to use models, because for number 5, you're going to use the rule that you come up with. Number 6 and 7 are just like the talk about it. You have a fraction, and you have to first write it as a sum of the unit fractions. Unit fractions, how do you know if it's a unit fraction? Aaron? The numerator is 1. So like when we did 5/8, we knew 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 was 5/8. How many unit fractions did I have here? Zari?
5.
5. So that means 5/8 has 5 addends when you add the unit fractions. Keep that in mind. But you also, not only do you have to write it as the sum of the unit fractions, but you have to find one more way to decompose it. I'm going to tell you, just think of one way you can do it using with 2 addends. Okay? Now, look at the back. Okay, so number 9. On this page, numbers 8 through 10 are word problems. So you need to figure out, okay, what are my addends? What is my denominator? What are my numerators? In order to solve the problem. And then you're going to use your fraction tiles to solve. So first, you need to figure out the equation. So I have to see an equation and the answer on the line. And then, of course, the unit. So for number 9, we have Miguel cut a cantaloupe into 8 slices. So I'm imagining a cantaloupe, and I'm imagining a boy named Miguel cutting it into 8 pieces. How many total pieces was my whole cantaloupe cut into? Carla.
4.
Cullen.
8.
8. 8. He ate 1 slice, so I'm imagining Miguel just eating 1 slice. And then his friends ate 4 slices. So I'm imagining a couple friends eating 4 slices total. What fraction of the cantaloupe did they eat? Who would like to help with this problem? Let's see. Have any of you that currently have your hand raised answered a question yet this morning? If you've answered a question yet this morning, put your hand down. All right. Well, I know it's more than Aaron and Zari and Colin. Okay. Keep your hand up. Lena. First, we have to find the equation, right? Are we going to have different denominators based on what we've done this morning, or are we going to have the same denominator every time?
We're going to have the same denominator.
We're going to have the same denominator every time. What is our denominator going to be?
8.
8. Why?
Because they have 8 slices total.
Because the total number of slices was 8. He took the whole cantaloupe and he cut it into 8 pieces. Now we know we're going to have, our addends are both going to have 8 as a denominator. Now we just need to find our numerators, and then we know we're going to add because the whole point of this lesson is adding like fractions. So let's think of Miguel's pieces. Out of those 8 pieces, how many did Miguel eat, Lena?
1.
1. So what fraction shows how much of the cantaloupe Miguel ate?
1/8.
1/8. He ate 1 out of the 8 total slices, so he ate 1/8. Now we need to think of his friends. What fraction of the cantaloupe did his friends eat?
4/8.
4/8. They ate 4 out of the 8 total slices, so they ate 4/8. Are there any other people that ate ate cantaloupe
No.
that we have to add together?
No.
No. So our equation is
1/8 plus 4/8.
1/8 plus 4/8. That's the first step to doing these word problems. Figure out the equation. Now we can just follow the steps from the, what was it, the build it? No, the try it. So what do we do first?
We add 4 and 1.
What do we do first? Go back to the try it. And what was the very first step?
We model 1/8.
We model our first addend, which is 1/8. Which fraction tiles am I going to use?
The 1/8.
The 1/8 tiles. How many do I need for 1/8?
1.
1. Now what do I do?
You model the 4/8.
I model my second addend, 4/8. What fraction tiles am I going to use?
The 1/8.
The 1/8 tiles. How many do I need to show 4/8?
4.
4. 1, 2, 3, 4. Okay? Now I have my models of each addend. What do I do now?
Now we add them.
We add them. And how do we show that? Like, how do we use our manipulatives to show that we're adding them?
We count.
But what do we have to do first before we count them?
Put them together.
We put them together. Now what do we do?
Count.
Count them. How many 1/8 tiles do I have?
5.
5. Which means Miguel and his friends ate
5/8.
of the,
Cantaloupe.
how do you spell cantaloupe? Okay, yes, I knew there was a random U in there. Okay, so that's what you're doing for numbers 8 and 10. You're figuring out, okay, what is the denominator? I know it's going to be the same for all the addends because we're adding like fractions. And then, what is the numerator? Figure out what each amount is telling you. Then number 11 is critical thinking with numbers. Number 12 is critical thinking with words. Look at the homework. You will get your own, a printed one, but it's set up the same way. Numbers 1 through 4 are just like 2 and 3 on the independent practice. Numbers 5 through 8, you have models right there. So you have to figure out the first addend and the second addend and then add them together. Okay? Because look, it says write an addition sentence for each model. So you need the equation and the answer for numbers 5 through 8. You have the models right there, so you don't need to use your fraction tiles for numbers 5 through 8 or your fraction strips because you'll be doing them at home. Hold on one second, Ethan. Okay? Numbers 9 and 10 are just like 8 through 10 on the independent practice. You need to figure out, okay, what does my equation look like? And then you write the answer with the unit. So on number 9 and 10, just like in the independent practice, I need to see the equation and the answer with the unit. So the whole back, 5 through 10, you're not just finding the answer, you're also finding the equation. Does everybody understand? So those are all worth multiple points because I need to see the equation and the answer. Number 11 is vocabulary. You're just explaining why. You're just answering that question in words. Any questions about the rest of the independent practice or the homework? Go ahead and get started. And then Ethan, what's your question?